So therefore, since CG is equal to GD, since CG is equal to GD, therefore the line CD cuts equal intercepts on the three parallel lines. And according to the theorem on intercepts, as I told you that even if one straight line cuts off equal intercepts on uh, three or more parallel lines, then all other straight line that intersects those lines will cut off equal intercepts. That means you will have this part equal to this part by the theorem on intercepts. Also, you will have this part equal to this part due to the theorem on intercepts, right? So therefore, the question here is find BG if AD is equal to 6. The first part of the question. See, AD is equal to 6 here. Now you see that since these two are equal, these two, and I can say B is the midpoint of AC. Also, I can say G is the midpoint of CD. It is given. Now, having applied the theorem on intercepts, now I will apply the midpoint theorem. See that in triangle CAD, let me first write this. Since CG equal to GD, therefore G is the midpoint of CD. G is the midpoint of CD. Also, you can say that CD, that G cuts equal intercepts. CD has equal intercepts. CD has equal intercepts CG and GD. Okay, CD has equal intercepts CG and GD. Therefore, AC has equal intercepts AB and BC. Okay, that is AB is equal to BC. That is B is the midpoint of AC. This we are getting from theorem on intercepts. Theorem on intercepts. Okay. Similarly, F is the midpoint of, is this F? No, this is E. E is the midpoint of FD. That is, oh, similarly, you can say not F is the midpoint, right? Just as you had written earlier. Similarly, FD has equal intercepts FE and ED. That is, FE is equal to ED. That is, F, in fact, E is the midpoint of FD. E is the midpoint of FD. Okay. So what have we shown? We have shown that B is the midpoint and we have shown that E is the midpoint. Now consider this triangle. Consider this triangle here, CAD, this blue triangle. If you consider this triangle here, what do you see? You see that we have already shown by the theorem of intercepts that B here is the midpoint of AC, and it is already given that G is the midpoint of CD. Therefore, in this triangle, I can apply midpoint theorem. If I can apply midpoint theorem, then what can I say? I can say that this length, BG, is parallel to AD, which is obvious because these two lines are parallel given. Also, what can I say about the lengths? That BG is equal to half of AD. And here, if you see in the question, you need to find out BG given AD. So if BG is equal to half of AD, and if AD is 6, therefore the length of BG is 3 centimeters. So therefore, we will write now in triangle CAD, B and G are midpoints of triangle of sides. What are the sides here? AC and CD respectively. Therefore, BG, that is this side BG, is parallel to AD and BG is equal to half of AD. BG is parallel to AD and BG is equal to half of AD. So according to the question, you need to find out the length of BG, and the length of AD is given to be 6. So this is 3 centimeters. That's what. Okay, so first part is over. We look at the next part now. Calculate the length of CF. You need to calculate this length. Okay, this length you need to calculate. Given GE, that is, this length is given to you. Okay, so what should you do? Again, apply midpoint theorem in this triangle here. In this red triangle, apply midpoint theorem. This red triangle, you apply midpoint theorem because G, you know, is the midpoint of the side CD and E is the midpoint of the side FD. You have already shown by the theorem on intercepts. Okay, so therefore you can say that GE is parallel to CF, which is obvious, it is given, and also that GE is equal to half of CF by midpoint theorem. And therefore, what is the length of GE given? G is given to be 2.3. Therefore, what is the length of CF? It should be double of G, which is 4.6. So let's apply in triangle DCF. In triangle DCF, G and E are the midpoints of sides CD and FD respectively. Therefore, GE is parallel to CF, right? G is parallel to CF and GE is equal to half of CF. Okay, you write here. Here also you should write by midpoint theorem. So here also you'll write by midpoint theorem. So that means what can you say? You can say CF is equal to twice of G or EG. And what is the length of EG given here? G given at 2.3. Twice of 2.3, which is 4.6 centimeters. Okay. So that concludes your part on midpoint theorem. The inverse of sine was cosec. You had sec. as the inverse of cos, and the inverse of tan was cot. Okay, that is what we saw. These were inverse trigonometric ratios, cosec, sec, and cot. The main trigonometric ratios were sine, cos, and tan. Now the question arises that first of all, that can one trigonometric function be expressed in terms of the other? Okay, so this rule, the first rule provides us a basis of changing one trigonometric function to another. For example, sine, this is the first, your first result. Sine will change to cos, sine can change to cos, and cos can change to sine. Sine can change to, remember, sine will change to cos, and cos can change to sine. How? See that if I have, suppose, sine, this is the result, sine 90 minus theta, 90 degree minus theta must be equal to cos theta. Also, cos 90 degree minus theta must be equal to sine theta. Okay. So let us take an example here. Suppose I have sine 35 degree. I want to express this in terms of cos. Then which one will you use? Look at this. Here, what is theta? Here, theta is, we'll use the second one here, not the first one. We'll use the second one, this one. Okay. Here, theta is 35 degree, right? So this is my 35 degree. And what about cos? Then what will happen? How can I write this? That means sine theta, therefore sine 35 degree, which is theta, is equal to, if it changes to cos, what we are going to do here is we change this sign to cos. Okay, remember this sign will transform to cos, and inside the brackets, after writing cos, inside the bracket what we are going to write is 90 degree minus this angle here, 35 degree. This is a very important rule. Please remember this. Okay, which is equal to, now you can subtract and write 90 minus 35 is what? How much? 55, right? So you see that sine 35 has the same value as cos 55. Okay. Another observation that you must make is that this 35, the sum of 35 and 55 is 90 degree. Okay. This observation you must make, which will be helpful for your sums later on. So sine 35 I change to cos. Similarly, if I have, say, cos 75 degree, I want to express this in terms of sine. So what am I going to do? First, I'll change this cos to sine. Then what is my theta here? This theta is my 75 degree. And inside, what I'm going to write is 90 degree minus 75 degree, which comes to sine 15 degree. Is this clear? Or any question? Yes, all clear. Next is that sec can change to cosec according to this rule. Sec can change to cosec. Cosec can change to sec. How? It's exactly the same rule. Sec 90 minus theta must be equal to cosec theta. And cosec 90 minus theta is equal to sec theta. Okay, so for example, if I want to express, say, sec 15 degree in terms of cosec. Then how will I express? I'll write cosec because sec can change to cosec. And then this angle here, I'm going to subtract from 90 degree. So that I'll get this as cosec 75 degree. Similarly, if I want to convert cosec to sec, what am I going to do? I'm I'm first going to write from cosec, I'm going to write sec, and then inside I'm going to subtract this 73 from 90 degree. Okay, so that we get sec 17 degree. So cosec 73 and sec 17 are same. Similarly, the third rule is that tan can change to cot. These you must remember, okay? Tan can change to cot and cot can change to tan. So tan, if I want to write, express tan 90 degree minus theta will change to cot theta, and similarly cot 90 degree minus theta will change to tan theta. That's the rule, that cot can change to tan. So again, a small example here, very similar to all the above examples. If I want to say tan 72 degree, I want to change this to cot. So I'm going to write cot here, and I'm going to subtract 72 degree from 90 degree. Get cot 18 degree. Again, note that the sum of 75 and 18 is 90. So when tan is changing to cot, and the sum of these two is 90 degrees. So that is why these relations are sometimes called trigonometric relations between complementary angles. Okay, trigonometric ratios of relations of complementary angles. That sometimes it's called. Say tan of tan cot 40. I want to change to tan. I like tan, and then inside I'm going to subtract 40 degree from 90 degree, so that I get tan 50 degree. So tan can change to cot, cot can change to tan very conveniently. These examples 1, 2, and 3, they just illustrate what I have just mentioned to you. Okay. Next, look at this example 4 here. This is a very important type of example. Please remember. Okay. Look at this. The question is evaluate or find the value of. So sine 72 degree by cos 18 degree. Minus sec 32 degree by cosec 58 degree. There is something very interesting here that you must observe in this problem. There are two things to observe. First thing is that sine here can change to cos, right? That means this sine you can change to cos, or remember, or you can change this cos to sine. Okay. Also, you know that sec can change to cosec. So this sec can change to cosec, or this cosec can change to sec. So what I do here is I change this sine to cos. So what I do also, this was the first observation, that sine can change to cos and cosec can change to sec. The next observation that you must make is that the sum of these two angles is 90 degree, 72 degree and 18 degree, 32 degree and 58 degree. The sum of these two angles is 90 degree. Whenever you see this kind of uh, observe this kind of a phenomenon in any problem, then you must change one trigonometric function to the any one of the trigonometric functions you can change. Okay, I opt to change sine here. So let's change sine to cos. So sine 72 degree when expressed in terms of cos, I can write this as cos 90 degree minus 72 degree. And this cos 18 I keep as it is. Remember, I want to change only one of them, not both. Okay. And the next one is, suppose I want to keep this sec same. Okay. And I want to change cosec to sec. So I can write this as 90 degree minus 58 degree. So in the first one, I have changed the numerator, that is sine to cos. And the second one, I have changed the denominator only. Okay, so now what happens? This becomes cos 18 degree, and this cos by cos 18 degree minus sec 32 degree divided by sec 32 degree. So this cancels 1. This also cancels. You get 1, which is 0. Okay. Now, if you see, I have solved here. Here I have changed the numerator. So as I told you, you can either change the numerator or the denominator, whichever is your wish. But remember two observations, very important observation, that sine here you have numerator, in the numerator you have sine, and in the denominator you have cos. And you know sine can change to cos. Also, sec you have in the numerator, cosec you have in the denominator. You know that sec can change to cosec. First observation. Second observation is that these two angles in the numerator and the denominator, the sum of these two is 90 degree. 32 plus 58 is also 90 degree. These two are very important observations that you must make. Example 5. Look at this one. Question is sine square 20, prove that sine square 28 degree minus cos square 62 degree is equal to 0. We start from the left hand side. Sine square 28 degree minus cos square 62 degree. Now remember, I told you the sine square 28 degree means sine 28 degree whole square. Okay. And cos square theta means cos theta whole square. Right. This is what I told you. Now also what you must know is that what you must observe in fact is that sine can change to cos or cos can change to sine. So what we will do here is we'll either change sine to cos or we'll change cos to sine. We'll not change both. Okay. So what we are going to do here is we are going to keep sine as it is. This time let us change cos. So if I change cos to sine, I must subtract this angle from 90 degree. Okay. And therefore this is sine 28 degree square minus sine 90 minus 62 is again 28 degree. So this is nothing but sine square 28 minus sine square 28 degree, which is equal to 0, which is equal to RHS. And that is the required proof. Any questions till now? No questions?
No, sir.
Next, what you must remember, yeah, this one I have shown you that sine can change to cos, sec can change to cosec, tan can change to cot. This is the first thing that you must remember, these relations here. Okay. And the next one is you have to buy hard these ratios. These are very, very standard ratios which you will require throughout, not only in your class 9, but you will require this whenever you are doing trigonometry after this. If you're taking science especially, you will require this till your PhD. Okay, so ratio that you must remember. Sine 0, sine of 0, what does this table mean? Sine 0 is 0. That means sine of 0 degree is, the value is 0. Standard value. Remember, sine 0 is 0. Next, sine 30 degree is half. Remember, sine 30 degree is equal to half. Sine 45 degree is equal to, sine 45 here is 1 by root 2. Remember, sine 60 is root 3 by 2. This one. Okay. And finally, sine 90 Sine 90 degree is 1. Okay. Similarly, for cos, what you see is cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is half, cos 90 is 0. Tan 0 is 0, tan 30 degree is 1 by root 3, tan 45 degree is 1, tan 60 degree is root 3, and tan 90 is infinity or undefined. Okay, these relations you can remember. Now, there's a small, uh, what should I say? There's a small observation that you must make, and this will also help you remember all the trigonometric ratios, the standard ratios, is that if you observe carefully, sine 30 is half and cos 60 is half. Remember that sine 30 and cos 60 are both equal to half. You can remember it this way. Another thing that you can remember is that sine 60 is root 3 by 2 and cos 30 is root 3 by 2 and they are equal. So sine 60 and cos 30 are same and both are equal to root 3 by 2. This will help you remember. Okay. Next, sine 45 and cos 45 are equal. And what are they equal to? Both are equal to 1 by root 2. Okay. Next, sine 0 and cos 90 are same. This you can remember also. And both are equal to 0. Sine 90 is equal to 1 and it is equal to cos 0. This you can also remember. That is, these two are equal. And these two are equal. Okay. Now let us come to tan. Tan 0 is 0. Very easy to remember. Now, see, sometimes people get confused between these two. Okay, tan 30 is equal to 1 by root 3 and tan 60 is equal to root 3. So how to remember? Remember that, see, 1 by root 3 is less than root 3, right? 1 by root 3, the value of 1 by root 3 is less than 1 by root 3 because you have root 3 in the denominator there. And you see that 30 degree is also lesser than 60 degree. So whenever you have between 30 and 60, whenever you get confused between the values 1 by root 3 and root 3, remember that since 30 degree is the smaller angle, we'll take the smaller value, 1 by root 3. Clear? Also, tan 45 is 1. That is also easy to remember. And tan 90 degree is undefined. Also easy to remember. So this will help you in remembering, but there is nothing like, there is no very simple rule for memorizing these. You have to sit and you have to memorize these values. The rule that I told you, they can only help you in memorizing. Okay, so that's let's see one more problem from these. Now these problems that I solved here, these are simply putting the values from the standard ratios. See that here. See here, you have cos 45. I've put the value of cos 45. Cos 60. What is the value of cos 60? It is half. So I've put the value of cos 60 also. Sin 30. What is the value of sin 30? It is half. So I've put the value here. Tan 60. I've put the value of tan 60 is root 3. I've simply put the value, simplified, and got the answer. So this problem, similarly for this problem also, I've simply put the values. See, sine to the power of 4, 30 degree. I've written this first as sine 30 whole to the power of 4. Okay. And I've put the value of sine. Similarly for cos 60 also, I've put the value. For cos 45, what is the value of cos 45 according to the table? It is 1 by root 2. And sine 90 according to the table is also 1. So that's simply I've put the value and simplified. There's nothing much to do here. Third one is a verification problem. Okay, these problems uh, you just need to verify whether the left hand side and the right hand side for that particular value of the angle are equal or not. Okay, so for example, if you see here, given x is equal to 30 degree, Okay, you need to verify that tan 2x is equal to 2 tan x minus 1 minus tan square x. That is what you need to verify. So we start from the left hand side. Let's see what the value of the left hand side is. What is left hand side? Left hand side is tan 2x. And the value of x that is given here is 30 degree. So twice of 30 degree, which comes to tan of 60 degree. And tan 60 degree, you know, is which one? 1 by root 3 or root 3? It has to be root 3 because 60 is a higher angle. Okay. So value of left hand side, you are getting root 3. Now let us see whether right hand side also we are getting root 3 or not. So now we start with the right hand side. You have 2 tan x by 1 minus tan square x. So what is the value of x? 30 degree. So 2 tan 30 degree by 1 minus tan square 30 degree. Now what is the value of tan 30? From the table, it is 1 by root 3 by 1 minus tan square 30. You can also write this as, let us first write this as tan 30 whole square. Then I will put the value. You can write directly also, but since I'm starting here, that is why I'm not writing directly. Tan 30 degree whole square. So now this becomes 2 by root 3 in the numerator. And here it becomes, you put the value of tan 30 as 1 by root 3 square. So this becomes 2 by root 3. You just need to simplify now. And this becomes 1 minus 1 by 3. You take the LCM in the denominator. It becomes 3 minus 1 by 3. Becomes 2 by root 3 divided by 2 by 3. So this is 2 by root 3 into 3 by 2. So these two cancel. Simply becomes 3 by root 3. Now 3 can be written as root 3 into root 3. This is cancels here. You simply get root 3. So therefore, what you see is that you are getting left hand side, the value of left hand side equal to root 3, and the value of right hand side also equal to root 3. So since left hand side equal to right hand side, hence verified. Okay. So stop here for today.